This is a video from section 6.2 in linear algebra. Let's take a look at problem 41. Let V be an inner product space. Prove that if W is orthogonal to each of the vectors u1, u2 through ur, then it is orthogonal to every vector in the span of u1, u2 through ur. Now, what do we know? W is orthogonal to vectors u1, u2 through ur. What does that mean? What that means is that the inner product of W with u1 equals 0, the inner product of W and u2 equals 0, all the way through until the inner product of W and ur equals 0. Now, let V belong to the span of u1, u2 through ur. Okay, so we're picking an arbitrary vector in the span. We want to show that the inner product of W and V is equal to 0. Now, since V belongs to the span of u1, u2 through ur, there exists scalars C1, C2 through CR such that V equals C1, u1 plus C2, u2 plus all the way through until CR, ur. So in other words, we can write V as a linear combination of vectors u1, u2 through ur. So now what we're going to do is take the inner product of W and V. But I'm going to replace V with C1, u1 plus C2, u2 plus ... plus CR, ur. So in other words, the inner product of W and V is equal to the inner product of W and C1, u1 plus C2, u2 plus all the way through until CR, ur. And now what I'm going to do is I'm going to break it apart. And so this is the inner product of W and C1, u1 plus the inner product of W and C2, u2 plus ... plus the inner product of W and CR, ur. Now, this can be written as C1 times the inner product of W and u1 plus C2 times the inner product of W and u2 plus ... plus CR times the inner product of W and ur, right? But this is C1 times 0 plus C2 times 0 plus ... plus CR times 0, since W is orthogonal to vectors u1, u2 through ur. But this is equal to 0 plus 0 plus ... plus 0. And that is equal to 0. And so we can say, therefore, W is orthogonal to V. And so, therefore, W is orthogonal to every vector in the span of u1, u2 through ur. And that's how 41 works. Now, let's go back here for a second. Here's something I left out that would be a good exercise. Now, to go from this first equal sign, I'm just replacing V with what we said V was, right? So that's a substitution. But what's allowing me to go from the first line to the second line? And then from the second line to the third line? Now, I told you how we got to the fourth line. It's because W is orthogonal to u1, W is orthogonal to u2. That's given, right? But what's making me go from first line to second line and then second line to third line? And that would be a good exercise as to figure out why. So I will leave that for the viewer of the video. Okay, that'll do it for this video for section 6.2, and we looked at problem number 41. Thank you.